that button. Cool. So just a brief bit of housekeeping from me, some introductions. I'm John from the Scale Factory. We're an AWS consulting partner based in London. We work with a range of customers across a variety of sectors and types of businesses, but we're particularly known, I think, in the AWS world for our work with SaaS businesses, for which we had a competency designation awarded earlier this year. We're also very active and experienced in the well-architected program, which is a review framework that we run on behalf of AWS for AWS customers. I'll talk a little bit more about that when we wrap up, because there might be something of interest in there as well. We're a Kubernetes certified service provider, which means that if you've got Kubernetes problems, and if you're using Kubernetes, you probably do, we can help you with those. And you can also buy from us through the government G-Cloud framework if you're a public sector user. Brief bit of housekeeping this morning. So we are on Zoom. Paul's going to kick off shortly and sort of take us through Pulumi. He's happy to take questions throughout the session, so do feel free just to sort of pitch in. Either there's a button at the bottom of the participants list. If you click participants in your Zoom session, you'll find that there's a button underneath that with a blue hand icon on it. If you press that, it's equivalent to putting your hand up. I'll keep an eye on that for moderation purposes. Alternatively, just unmute and feel free to throw a question at Paul as he's in flow. He's quite used to this sort of dynamic, I'm sure. Do use headphones if you're going to be talking. It's a much better experience for everyone. And if you're not speaking, do hit the mute button. If you're not a regular Zoom user, you might be aware that Zoom has a sort of push to talk, walkie-talkie style feature. So if you're muted and you want to talk, if you hold down spacebar as Zoom is focused, then you will be able to talk whilst the spacebar is held down. So pro Zoom tip there for those of us who've spent a lot of time on it recently, which is probably most of us, to be fair, given the current global situation. As I say, do feel free to introduce yourselves in the chat, and I will now hand over to Paul and let him do his thing. Paul, over to you, mate.
Thank you. Good morning, everyone. John, seriously, that is the best Zoom tip I've ever seen. I've never known. I've given so many Zoom talks, and that's amazing. Okay, so thank you so much for having me speak here this morning. So there's a few things I want to go over. Firstly, I want to just talk about Pulumi in general and what Pulumi actually is. Now, there's a lot of misconception because of our messaging at this current point in time. We're reviewing that messaging, we're thinking about that messaging, we're taking on feedback a lot about what people are saying here, so that we can learn and make it more palatable for people. And I want to show a couple of demos that shows like Pulumi is actually very straightforward and declarative in the same way that existing tools already work. And then I want to show some differences between how Pulumi works and how the existing tools in the ecosystem work. So my name is Paul Stack, as John said. You can find me at Stack72 or paul@pulumi.com or anything. I'm more than happy to follow up if you don't want to talk directly on this call or answer any questions, but please do just unmute, ask a question as we go through, because it's really important that we can answer the question in the same context that you were looking at it as. Okay, so and thanks to Pulumi, they've let me give away 2 t-shirts for 2 of my favorite questions, because we usually get some interesting questions, and the t-shirt has our logo, which is the Pulumipus. So it is a platypus, but it's a platypus superhero. So, and it looks awesome. Okay, so we have identified at Pulumi that there are different companies at different levels of their cloud transition. Okay, so like, you have, even though the cloud has been a thing now for a number of years, there's still a lot of people who just haven't had the opportunity or haven't had the need to move to the cloud. But because of like a situation like this, like COVID, the acceleration into the cloud is becoming a lot more apparent for a lot of companies. So, you have people at V1 sort of their traditional cloud move, and they've just basically picked up their entire data center and just moved it into the cloud, and they have like an n-tier style architecture of like a couple of a number of app servers, a number of database servers, or maybe a load balancer that sits across the top of them, and maybe some DNS, and it's like you know, not really a lot of stuff they do. They're possibly taking advantage of something like Ansible to manage the servers as like a long running time, or maybe Chef or Puppet or something like that, or actually they could even be hand manage them. You just don't know. And it's and not, you know, it's not been too scary for them to move into that cloud, but you know, they're able to still do it. Then you have people who have like evolved a little further on from that, where they realize that they can take advantage of maybe something like containers, as well as using that, you know, start to bring in some SaaS-based tooling like Datadog or New Relic or these different types of things. And they're starting to become a little more transitional in their cloud infrastructure. And then you have people that are like building like what we call modern cloud infrastructure. You know, you've probably heard cloud native, you've heard all these different terminologies that can be used around it. You know, you're definitely taking advantage of like a container scheduler. Maybe it's Kubernetes, maybe it's HashiCorp Nomad. You know, you could be just taking ECS or Azure Container Service. You're definitely taking advantage of like, you know, storing data outside and processing it, maybe machine learning and so on, and could even be taking advantage of functions. Now, Pulumi is different here because what we actually do is we're targeting the V3 cloud infrastructure by default. So we're making it, we're trying, I have to be very careful here, we're trying to make it easier for people to move into this V3 style architectures, but we still target the V1 and V2 style architectures as well that actually allow you to deploy and run your applications and your systems in production. Now, traditionally, some of the tooling out there is much more targeted to V2 style architecture because they haven't been able to like sort of get up to speed around, not get up to speed, but be able to build dynamic functions and be able to build like APIs around Kubernetes and Lambda and stuff like that. So, you know, it's not the fact that we're better, it's we're targeting a different segment, but we still allow you to do the other things. Whereas like traditional tools sort of target V2, but still allow you to do V1 and V3. So we're competing, but we're definitely like in a different part of that competition. So like just quickly, what is infrastructure as code? You know, it's just idempotent code that you run again and again, not messing around in the console, actually having some real visibility of what's going to change. And then of course, being able to repeat it and do it again and make it predictable. So we are definitely in the infrastructure as code space, but we like to class ourselves as the modern infrastructure as code space. Now, this is where we have taken a little bit of a hit, and I'll be totally honest here, because we start to say things like real languages and we use pompous words, and it maybe sounds derogatory to people who write in YAML, who are written in DSLs and stuff like that. I promise you that's not the case. This is a hang up of that the company has had for a long, long time, but have realized that that's not actually what we're trying to suggest. Now, the reason that real languages are important for us, or languages as we're now calling it, is important for us, is that you can actually take advantage of the ecosystem underneath the tool. Okay, so like we can use our favorite tooling, like our IDEs. Okay, we can get our autocomplete, we can get our refactoring tools, we can actually implement our testing tools like GoTest or Mocha or PyTest, anything like that, and we can create, you know, pass code around using packages, like actually semvered packages, which sometimes is quite important for lots of people. Now, we do follow the same sort of CLI style familiarity so that people can integrate us into their CI/CD pipeline. And of course, we get all of our audit trail changes. So it's purely real languages in the fact that it's what people like to use, the tooling that people like to use and the ecosystem that they're in, rather than it's better because it's real languages. That kind of brings us to the idea that we're no longer infrastructure as code, but we're actually starting to move into the ecosystem of infrastructure as software. So, you know, it's definitely a case of testing, code review, CI/CD, semantic version, APIs, abstractions, all of these different things that help us like build, like drive in the correct direction and move in the right direction of where we're going. So Pulumi is built on a foundation of providers. It's important to say in advance, the providers, we actually have written a tool that will allow us to get the schema and the CRUD APIs and endpoints from Terraform providers, but we do not use Terraform under the hood. We do not use Terraform binary. You will not have any dependency on Terraform in your code, anything like that. We literally just pick up all of the details using our application or the app that we wrote, and we pull it across into Pulumi, and we build the Pulumi schema. Okay, we know that reliance of Terraform cannot continue in the long term of the company, and we are actively trying to move away from that at all points. This was purely a get to market strategy, and it has actually been quite effective in being able to leverage the awesome work that the Terraform open source community have done. So there's thousands and thousands and thousands of hours that people have put into the Terraform providers that we're actually able to take advantage of. So like we're looking maybe as like, you could think of us a feeling that the Terraform providers are like an open standard and we're building on top of them. Okay, on top of those providers, we can build patterns and libraries, and that is like simple APIs, packages. If you think of it as like Terraform modules, if you're a Terraform user, then you can actually build a similar thing using Pulumi. And then even on top of the libraries and patterns, we have built the ability to create default infrastructure in AWS and Kubernetes, and soon to be GCP and Azure are using something called Crosswalk, where under the hood we're actually adhering to the best practices that Amazon or the cloud providers give us, and it makes it very easy for people to not know need to know all of the glue that holds all of the different pieces of the cloud together. They can get started in a much simpler fashion. Boring. Okay, so Pulumi, I told you, is like infrastructure as code, and it is declarative. So even though we're using imperative languages, it is a declarative syntax. So you can see you define your constants, you define your resources have parameters and arguments, and you can actually create relationships between the resources. Notice that the VPC security group IDs references the security group from above. Okay, that is the most basic setup of a Pulumi application. There is no programming knowledge required in order to get going with Pulumi, and that is the misconception that I want to break within our community. Now, if you want to take it a little further and you need to introduce a little logic, then you can introduce the programming constructs. So here we're actually creating subnets if public CIDR subnets variable is not equal to null, and we're actually taking advantage of splitting the list of public CIDR subnets down, and then for each item in the list, we can actually create a public subnet based on the top of it. We have our multi-provider workflows where we have the outputs of one cloud being or the output of one package available for the input of another package. I'm going to demonstrate that a little bit. In a while, we can create our APIs. I may have time to demonstrate how we would build a package and actually share a package within our application. But one of the most interesting use cases for us is the ability to do things like advanced orchestration. Now, here is the benefit that we get because we are built on top of language ecosystems. We can take advantage of the language ecosystem. If there is code that is available in the platform, in the language platform that you are writing your Pulumi code in this case it's TypeScript, you can actually ingest any package that is currently on the internet that will allow you to do a job. Now, it will become apparent here is what we're doing is we're saying, I want to deploy 3 replicas of my application into Kubernetes. When that has been finished and when those 3 have been deployed, we are going to talk to the P8 library, so Prometheus library, and we're going to call some code that we wrote called check app metrics, passing in the name of the application. And inside that P8 check app metrics, it's actually just ingesting the Prometheus SDK that was written as part of the Node.js ecosystem. And once we're fine and everything works and everything is good as expected, then the application will continue and deploy our next 10 replicas within the system. Now, usually what would happen here is you would deploy 3, you would go to your monitoring tool, you would actually check that your monitoring tool was all okay, and then you'd come back to your application and run another Pulumi up. But because Pulumi is an imperative application, it will continue and it will wait until it actually passes the criteria that it needs, and then it will continue on as expected. So you don't need to break that workflow into multiple segments. Pulumi can do that for you as part of the code. We say we're test driven, and we actually are, because we have now created the ability that you can mock the responses and requests to the cloud, which means that developers who are writing Pulumi code do not even need credentials on their local machine. They can actually mock the responses from the cloud because they're well-known responses. And usually what happens is that people are waiting for resources to be created in the cloud and verifying that their code is working as expected. We believe that there should be a much tighter feedback loop on that, and I can show you examples of how that actually works. For me, the most important part of Pulumi, and it's probably my favorite part of Pulumi, is that we actually have secrets management built into Pulumi. So Pulumi has a secrets engine. When you create a Pulumi application, you can tell it what secrets engine to use. Currently, we support AWS KMS, Azure Key Vault, Google Cloud KMS, and HashiCorp Vault. Okay. Now, when I say we have a secret engine, you do not need to wrap Pulumi in any other tool. It will actually interact with those systems as we go. And I am going to show you a demo of this. By default, we use something called Pulumi KMS. The Pulumi SaaS is currently stored in AWS. It's running in AWS, and each customer, each project gets their own KMS key, so that when you actually, if you don't like switch your own secrets provider on, we give you a secrets provider by default so that you can interact with it. We're trying to force people to use secrets as we go. So the typical layout of how Pulumi works, the architecture, is that Pulumi is all CLI driven, client driven. The credentials sit alongside the CLI. So it reads them from either config or it reads them from environment variables. The CLI will then interact with the cloud, and it will store the state by default in api.pulumi.com. Okay, so this is in the Pulumi SaaS. There is no storage of credentials to Pulumi. Pulumi will not read your environment variables, actually store them in your state and keep that in the SaaS. We don't want your credentials at all. I don't want to be dealing with anybody stealing any cloud credentials from Pulumi. So as long as you configure Pulumi correctly in the way we actually suggest that you do it, then you will not store anything on there. It's really important to say that the Pulumi SaaS will never be able to interact with your cloud directly. Okay, it has no idea what cloud it is. It just knows that it's a list of resources and how different things happen inside the resources. If you don't want to use the SaaS, you can log into your own backend. So you can log into an S3 bucket, a GCP, or Google Cloud Storage bucket, or an Azure blob, and it will store the state there as expected. So you do not have to use the SaaS. We do not track anything for people who are not using the SaaS, and we have a lot of companies who are not using our SaaS, and we're totally happy with people not using our SaaS. That makes it free and open source forever, and you never have to pay me, even though I like being paid. So it's really important to talk about one concept before we go. So Pulumi has this idea of an organization. An organization has multiple projects, and a project has multiple stacks. So a stack in Pulumi, you can think of a stack as an environment. So it's a segmentation of a set of resources from another set of resources. For those who are familiar with Terraform, it would be very similar to how Terraform workspaces work. Because you could have a stack that's for the dev stack, the prod stack, the testing stack, the production stack, but you can actually also have stacks for individual developers, and they would all use the same Pulumi application, but they can actually interact with their environment independently of each other. So you have no like hard-coded dependency between them. Now, we like to actually suggest that you architect your code correctly. So we like to say things like you would have a project for your networking layer. You would then export the values that are required for the networking layer, and then the database layer or the application layer or the cache layer can then ingest those values and you can build upon it. So we like to think in terms of if somebody ran Pulumi destroy, what would it affect? And it should be the smallest surface area of your system that you can actually possibly do, because you don't want to be destroying everything in one go. So if you architect it nicely from the start, then you actually get a lot of safety built in as you go. So let's go and write some code, okay? Because does anybody have any questions before now? Nope. Awesome. Okay, cool. So let's go and actually write some code, and then we can actually see it in motion. So let's not do that one. Let me just increase my size a little. Okay, so make their demo one. So Pulumi is a CLI tool by default. And if you run the command Pulumi, it will give you like nice hints and nice UI around what it actually needs to do. But by default, Pulumi tries to tell you that everything starts with Pulumi new. So if I run the command Pulumi new, then it will actually give us all the available templates that you can use in order to scaffold an application. So today I'm going to use AWS TypeScript just because I have a lot of TypeScript demos that I've written, and of course I can write it in any of the different languages. You don't have to go with this, but you can see that there's C#, Go, JavaScript, Python, TypeScript across all of the different clouds, and it even has like some Kubernetes examples, but we're going to build our own Kubernetes example as we go. So let's create C# TypeScript. It will ask you for a project name. The project name will be Scale Factory 1. Yeah. Description, so that you actually know and you can find it and you can get information about it. We're just going to choose the default, and you can say a stack. So we're going to call the stack demo 1, and we're going to deploy into the furthest possible region away, US West 2, because why not, right? Like, let's see what happens. Unfortunately, this is JavaScript, so it's going to install the entire internet, but it doesn't take too long to do. So, and I'm just going to open my IDE so people can actually see what's going on in here. Where are you?
Well, can you talk a little about the architecture of Pulumi as far as its support of multiple languages, and how, therefore, each of the languages has a sort of parity implementation of what you can do with Pulumi?
Absolutely. Great question. So Pulumi has a central code gen, and we have templates for each language. And as soon as a function is added into the central code gen, we literally have a for loop. And for each language in the list, it generates the same functionality using the templates that have been created, and it pumps out the SDK. But it's not just the SDK for each cloud, but also the fact that even our the central Pulumi code around, you know, the helper functionality and stuff like that is also created in all of the different languages that go with it. So it is 100% scaffolded. And as soon as a new feature is added, it is added in all languages by default. There is one exception, and that's something called dynamic providers. But we'll talk about dynamic providers a little later. That's like a proper advanced use case where you actually do need to know some level of programming in order to get to it. So I try not to like scare people showing them dynamic providers.
Am I right in thinking then in your implementation of the sort of core of Pulumi, the interaction with the AWS SDK, for example, is something that you've built in Go, and then there are bindings for the other languages. So there's not a lot of cloud smarts in those other language bindings. That's literally just an interface to what you're doing in the Go infrastructure.
You know what? I can actually show you what it is. Because I actually have the code open right now, funnily enough. Why are you not giving me? Here we go. So this is the library that actually takes care of all of the cloud bindings, and of course it will not open. It's just crashed on me. Amazing. Let me just quickly quit my IntelliJ. Come on. There we go. Okay, one instance. That's fine. So what this is that between the language bindings and the cloud bindings, we have protobuf implementations that talk back to the central Pulumi engine. And the central Pulumi engine will then allow us to talk directly to the cloud. And we have created this thing called TF Bridge. As you can imagine, the Terraform Bridge, because you know that's where we're picking up all the details from. And inside the provider, it allows us to, if I just show you, it actually, where are we? So it will allow us to use the invoke, and it will actually build, and even it will use like all of the correct imports from Terraform because of the fact that we've picked up the schema. So it will translate it exactly to what the Terraform schema requires because we picked it all up, and then it will actually make the invoke on its behalf. So everything is written in Go, and the fact that it's written in Go just means we have protobuf endpoints that actually support between all of the different languages and all of the different clouds. So a typical cloud schema itself is extremely simple. So if I go into Azure, well, that's definitely not something you want to see because that's like something that's not public yet. So good thing I didn't show that one. But if I go inside and show you the SDK for like Go for Docker, then you can see it is literally just like structs and pointers that are passed around, and those are actually pushed into the central engine, and the engine is able to decipher all of these different pieces, and it just has like a couple of functions like new container or get container, and everything else happens inside the engine itself. So the language SDKs, the cloud SDKs are pretty much like just Pocos, like just, you know, plain old object style systems, and we push them around in that manner.
So I think the message here then is that regardless of whether I choose the Python bindings or the TypeScript bindings, I can do exactly the same with whichever clouds I want.
Absolutely, 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 and that's really important. So thanks for like helping make that distinction. Okay, so here we go. Let's go back to our. Why do you not want to work this morning, IntelliJ? IntelliJ is really like tired as well. It needs its coffee too. Come on.
It's the peril sensitive plugin for IntelliJ. It knows when you're doing a presentation and screws you over.
Right.
You pay extra for that one, right?
I get my IntelliJ for free. So I'm surprised this works at all. Okay, now it'll work. There we go, there we go, there we go. So there's a couple of pieces to notice here. Enter presentation mode. Okay, cool. So inside the scaffolded application, of course, we have our node modules, we have our package file, you know, it brings in like the defaults that we actually set it to be. It has, we'll come back to this file in a second. It has a Pulumi YAML, which has the runtime. So, you know, Pulumi knows what runtime this application needs to be running under the hood. It has an index.ts. It has a pulumi.stack.yaml, and this allows us to segregate stack between config between stacks. So each stack can have completely different config from each other. But the meat of the application in this case, because it's TypeScript, sits in index.ts. So the first thing we have the helpers, we have resource declarations, and then lastly we have the exports. Okay, so the helpers actually allow you to create and interact specifically with the clouds themselves. Okay, but also it implements by default the Pulumi library. So that's when you can start to take advantage of the central features like config and you know, secret management and all these different pieces, which we're going to build up and show you a demo of right now. Then we create a resource declaration, and inside AWS and Azure and GCP, we try to keep sub-modules to be similar to how the cloud actually represents it. So in this case, we have S3, but if I just say const x equals new AWS dot, then you can see it says like API gateway, app mesh, app sync, auto scale and backup, batch, EC2, you know, CloudFront, CloudFormation. We've tried to sub-module all of the systems that sort of work easy together. And then even inside an individual package, you get all of the different functionalities that's required in here. So like bucket metric, bucket object, bucket policy, and so on and so forth. So each resource has 3 arguments required, or excuse me, 3 arguments that are available inside the resource constructor and how you build it. So we have a name, and that name is used for the Pulumi state. It has any arguments that you want to pass in, and then any optional arguments that that Pulumi actually specify, including things like custom timeouts, whether you want to protect this object so that it never is deleted by Pulumi, whether you want to import it, etc., etc. And in the args, it's things like ACL, okay, you know, like the typical things that go with as part of an S3 bucket. And then lastly, we can export any variables that we require out of our application so that they can be used either by people using the CLI or also people like ingesting the Pulumi stack further up. So if I go back to my code and if I say Pulumi up, then what it will do is it will build a preview of exactly what it's going to do. In this case, you'll see it's going to create the stack. Stack will be a combination, the stack name will be a combination of the project name plus the stack name, because we try and like, you know, multiple stacks within the system. And then it will tell me that it's going to create an S3 bucket as part of that stack. We can have a look at what the details is. So the interesting thing here is that the bucket name that it's going to create is my bucket, which relates to here, but it has a random string on the end. So by default, Pulumi uses auto naming. The reason that is that we try and encourage people to build their systems in the cloud in a HA manner where you can create a new instance before you have to delete the old instance. But there are some parts of the cloud in which you cannot create a new instance using exactly the same name. A launch template in EC2 would be a great example, or a storage account in Azure, or an S3 bucket would be another example. You actually have to create something with a new name before you can actually use it. You can't create something with an identical name. So we can go ahead and say yes, because we're happy with it. And we will get an output here. So there's a couple of things happening in this. It is actually building the app under the hood. It is compiling the app. And because it's compiling the app, it will tell us in advance if there are any errors. In the same way that if I go into my IDE, and I can actually say random property test, my IDE is telling me this doesn't exist. It's not actually there because we're actually able to use the plugins from the language ecosystem to tell us that. The same thing happens when we are building in advance. We get compile time errors about the code. And if we go back, then AWS S3 LS my buckets C90B7E1, and I haven't set a region, I bet you. Oh, it's there. So I'm not getting a 404 because if I remove that figure, you know, there's nothing in that bucket, but then there's no such bucket actually being called. So our bucket has been successfully created. And then the last thing, just to show you in terms of the fact that it's declarative syntax, I can actually say owner, and I can say stack 72. And if I run a Pulumi up again, Pulumi will tell me that it is only going to change the tags and nothing else.
So Adam's got a question. Adam, do you want to fire off?
In the preview, it had a different suffix to the bucket name than the one that it outputted. Could you speak a little to that?
So that's the auto naming that I was just talking about, where it will actually auto name by default. But you can switch that off, of course, because if we don't want the auto naming, we can actually specify that the bucket needs to be called demo, and you are explicitly telling Pulumi, I do not want you to auto name my bucket in any way, shape, or form. Specify this as the name.
Okay, I was just surprised that the output came out different than the preview.
Yeah, it's something that actually gets a lot of people, and it's something that we need to actually, like, even in the diagnostic that comes back as part of the plan, we should actually be able to say this is an auto-named resource, right, so that people can actually see in advance, and then a link to the documentation. I actually need to write that down. I've talked about that like 5 times and never gone and actually implemented the feature.
Right, okay. Thank you.
So part of CLI. Sorry, I'm just writing myself a note. So that is exactly how Pulumi works, as far as like the CRUD operations. I have no Terraform on my machine. I have credentials on my machine, so it's able to read those, but I can guarantee that I've just run a destroy, and the account that I'm using has about 3,000 test buckets in it. So, and it's only a targeted destroy to that specific bucket. So it is, is definitely keeping its state. You can Pulumi stack export at any time, and you can see the state that is actually being held about your application. Now, it's really important to tell you, state is not as big a thing in Pulumi as it would be in Terraform, because Pulumi stores things in a much more different fashion. Okay, so like our resources, our URNs of our resources are not like constrained to like positions on disk or things like that. So we have a URN that's like, this is the stack, this is the project, this is the type, and this is the actual like auto naming. So you can refactor till your heart's content. It's not really like constrained in the same way that having to walk the entire DAG every time, because we don't need to do that. We're an imperative application. So we walk the tree down until you actually build a relationship between the system. So it's different in that sense.
So one of the things that we've seen when we're working with Terraform, sort of refactoring things from mods and stuff, you find yourself having to spelunk in the state to move an object around from between modules. Is there something about how you store state that makes that a non-issue in the Pulumi world?
Yeah, because so in Terraform, like for example, and I'm not saying that they're wrong here. I used to work on Terraform, by the way, in case anybody like wants any background. So I was part of that decision. So like the module that you're stored in and the file that you're stored in is actually part of the URN of a Terraform state resource. But we decided that that's probably not for us, because it is in a language ecosystem. It is like, people are much more used to refactoring and extracting methods in like their ID than they would be in something like a DSL. So we needed to give people the fluidity to actually move stuff around. The only thing that you're actually stuck with in Pulumi is a resource cannot move between stacks. Okay, so like you're never going to move a resource from dev to prod. And if you actually need to move it from like the networking project to the database project, then at that point we can actually offer you an ID and an alias so that it will actually be able to do that in advance. So for us, like I think in the year and a half that I've been using Pulumi, I think I've only had to interact directly with the state maybe 3 or 4 times. So it's much more of a non-issue than it would be elsewhere.
Yeah, good. And the other thing that I've sort of noticed, you're running Pulumi up in the sort of Terraform landscape. We're familiar with the sort of plan and then apply approach, like and you're managing state, and so I'm sort of assuming there's something that looks kind of the same that we're not seeing here.
Yeah, it's exactly the same. Like it will actually build a plan in advance. But Pulumi lacks the feature right now where you can save that plan for later execution, but that will be coming in 2020 later in the year, because a lot of people are actually asking for that. But it's exactly the same thing. You're pre-compiling your application. As soon as you pre-compile your application is ready to be deployed, and that's the way like a Pulumi app works. So you don't have to walk the entire tree every time, as long as because Pulumi works on promises. You can have outputs and inputs which actually satisfy like a lot of different like pieces of the puzzle. So under the hood, it is I'm going to say it's much simpler than Terraform, because of the fact that they had to build like the whole amount of work around the AST and all these different pieces, because it's not able to take advantage of the actual like the language runtimes and the language hosts that we have. So we get a little bit for free there, and of course we get a lot for free based on the Terraform schemas themselves.
Yeah, gotcha. So I've got a question from Thanos and also then from Mark.
Hi.
Yeah, hello. Thank you, Paul, for this. So I've got 2 questions. I think they're slightly related. The first one is, what is Pulumi's business model? What's your revenue model?
Great question. So the business model is we have a Pulumi SaaS, and we will, you can pay us to manage your state, and that will be your back end, and it will actually like take care of all of that. You don't have to worry about backing up your S3 bucket or anything. We'll actually take care of that. That's the business model. I'm going to say we have lots of customers right now. I can't tell you how many, of course, but we have some rather large customers as well who take this as an enterprise offering on site, so that they actually can have their own Pulumi SaaS running behind their own system and manage themselves. And we will continually offer them updates. But we're doing quite well right now. I'll say our revenue is actually quite good at this point for such a young company.
Thank you. So that raises another question besides my second one, which is, why would I go to your SaaS solution versus using my own S3 bucket for the state? What is it? What's the added value of storing my state to Pulumi SaaS?
So great question. The SaaS doesn't just give you the state management, okay? The SaaS gives you RBAC so that different people can access different projects, but it also introduces this idea, what we call crossguard. So it's like policy as code, where you can create policies that people who are running infrastructure in your organization have to adhere to. So like your security team can write policies like you must not have public S3, public writable S3 buckets. You must not have security groups that are inbound access to the world or to port 22. And you must, your database team can write specific policies like you must be on no later than X version of Postgres or MySQL, because that is the latest tried and tested within your organization. So, it's not just the SaaS storage, it's definitely around the RBAC, the identity access to the SaaS, as well as like the policy management. Policy management is a big thing for us.
Policies and compliance. All right, I understand.
And it is definitely, it's the policy as code style. How I wrote my Pulumi application right there, you can write a policy in exactly the same style format.
Excellent. The last question I have is for the longevity of Pulumi. What can be said about that? And, roadmap, plans, 5-year vision, whether you're planning to, launch Pulumi 2.0 and have backwards breaking compatibility issues.
Okay, so we're already on Pulumi 2.0. We launched Pulumi 2.0 in April this year. We have an aggressive roadmap. The reason we're actually revving major versions in the product is because we are trying to offer that backwards compatible, that Semver style argument where we don't break people by default. We don't just go and change APIs. That is what Semver is. That is what the major version is. We already have our plan for Pulumi 3.0, Pulumi 4.0. We only took Series A funding like 2 years ago. We're not in the situation right now where we even need to take Series B at this point because we actually have some very large customers. One of our largest customers is Snowflake in the US.
So you are profitable?
Sorry?
You are profitable?
Yes. And Snowflake is actually filed for IPO yesterday. They love what we're doing. We also have Mercedes-Benz. We're working with some very large consultancy companies across UK and Europe that may or may not start with like the letter A. So there's like a lot of people who are taking advantage of what we're offering them. So yeah, we're definitely a company that's around for a while. One of the things that I always tell people if they're worried about that is every piece of what I've showed you today so far is open source. Please feel free to fork it and keep a copy because it is actually, it's Apache 2. You can take it, you can do what you need to do with it. And even if, God forbid, anything does happen in the future, you still have all of the code that will actually allow you to make things run. So, John, you were muted.
Sorry, I'm focusing the wrong window. Good question, Stanos. Let's go over to Marco's questions.
Cool. Thanks, John. Hi, Paul. So as we know from the Terraform, the usual issue with the remote state is that you are storing secrets there as well. So can you talk a little bit about where secrets are stored in Pulumi, please?
Thank you so much. My demo too that I just typed on the page is exactly about all of my secret demos. So it's a perfect time to talk about that. Okay. So let's actually go and do that so you can see and we can build it as you're asking the question. Okay. So let's Pulumi new TypeScript. And if this time I'm going to call it scale factory secrets. I'm just going to create the dev stack for now. And so there's two different ways that you can load secrets in Pulumi. One, you could do it via the CLI to load it into your configuration and mark it as a secret. And secondly, you can actually mark it in your code as a secret engine itself. So if I just have to install one more package at Pulumi/random. So it's the same as the Terraform random provider, but I'm going to show you how we can interact with secrets in this fashion. Okay, cool. So that'll just take a second just to install the plugin and the package. Now, if I go into my application right now, and if I say import star as random from at Pulumi/random. Has it finished? Okay, it has actually finished. Okay, cool. And then I'm going to say const my secret equals new random password, and I'm going to say demo1, and let's try and be good people and create length 30 and special characters true. And then lastly, what usually happens is export my secret val equals my secret dot result. So I know that just because I've given this demo 100 times that the output of this secret value is actually stored in the result parameter in the output. And if I go back and I say Pulumi up, and I'll take it out of interactive mode. So this is like CI mode. And it's actually just doing it right now in the background. You're not having to like make any scale. And this is usually what happens, right? We have a secret that comes out, and stack export. And you can actually see that it sort of proliferates its way through all of the state files. So let's access the other part of Pulumi, which is the secret engine. And if I copy exactly the same declaration and make it demo2, and after args, we have options, and we have something called additional secret outputs. And we need to pass the result field, the parameter name of result through the secret outputs. And then if I export const my secret val2 equals my secret val2 dot result, then what I will see in the output, and this is really important, is that Pulumi has created a secret object. And Pulumi doesn't know if it's an int or a string or a bool or whatever it is, but it's actually proliferated the whole way through as a secret. Now, if I Pulumi stack export that, then not only is in the output as proliferated as a secret, but it's also stored in the state as a secret. Now, this is using Pulumi KMS by default. So this is a KMS key that is assigned to my local project and my local stack. But let's change that. So let's Pulumi stack change secrets provider, and let's change it to be my own managed KMS ID. Okay, it doesn't have to be the Pulumi SAS in any way, shape, or form. And what Pulumi will do in the background is it will look through all the state file. It will decrypt and re-encrypt using the new secrets provider. And if I Pulumi stack export now, you will see that it has changed state. So it now has a V1 style system on the front of it. So, and even in my Pulumi stack file, we have our secrets provider. So we actually have the KMS key alias right there. We have an encryption key. So that's not, of course, how you decrypt it, but that is what Pulumi is using as the salt in order to actually do this, or not the salt, the actual key itself. So this is now in a fashion where you can, even if you check this file into source control, it's okay. Okay, let me rephrase that. It's not okay, because we definitely don't want to be like putting any of our secret information on the internet, whether it's encrypted or not. But the fact that it is encrypted means that it is safer, and that people would still need to have access to your KMS key before they can decrypt any secrets as part of it. So anything that we need to push through, so let's push the length through, and let's push special through. And if I Pulumi up right now, and then I stack export, because I know I only have 9 minutes left, so I apologize. You'll see no values have changed, but if I Pulumi stack export, you will see that special result length, they're all now encrypted using the same fashion, but of course they all have different variations of the cipher text that comes out. Now, it's really
Adam,
important.
you have a question. You're going to go ahead.
One second. It's really important to say one more thing. So when you need to set like the equivalent of Terraform variables that need to be read as part of your application, we have this idea where we have Pulumi config set, and I can say my secret database password, and I can say password 12345. Now, Pulumi by default has no idea that that's actually a secret password, so it stores it in plain text. But if I say -- secret, it will encrypt that same password using the same functionality, the same key as it did before. And then inside my application, I can say, you know what, let's interact with that configuration just so you can show that it's safe. So if I say conf equals new pulumi.config, so let's load the config block. And then if I say export x equals conf.require secret, it needs to be a require secret because of the fact that it is going to be read in as secret, so Pulumi won't be able to read it any other way. And it's not config, it's conf.require secret, and it's my secret database password. So in case anybody tries to circumvent the system and like send you any pull request that tries to output any of your secret information. Oh, I take that back. If I Pulumi up, you will see that it is actually goes the entire way through the system as a secret in that fashion as well. See, X is now a secret. So there was a question.
Hiya. Yeah. You're using AWS KMS as a backend for the secrets there. Is that a requirement for any Pulumi stack there, or is it?
It can
do you have equivalents for other?
Yeah. So if you Pulumi stack init help, you will be able to see that you can use Azure Key Vault,
Gotcha.
GCP KMS, or your HashiCorp Vault.
Gotcha.
So, yeah.
Cool. Thank you.
So you do not have to use the Pulumi SaaS in order to do your secret management. And a lot of people bring their own KMS keys. The nice thing about bringing your own KMS keys and using this secrets provider is that you can actually rotate the keys easier. Because if you need to create a new one, or your key has been leaked, or someone's expired it by mistake, just run a change secrets provider, and Pulumi will loop the entire thing and change it. So I can actually show you what it does here.
Gotcha.
So if you have a look at the stack file, the pulumi.dev.yaml, and if I Pulumi stack change secrets provider, and let's change it back to like default. Come on. It's working in the background, and you'll see it has actually changed it back to use the Pulumi SaaS. So you can rotate your keys as much as you need to.
Nice.
Marco, I hope that answers your question.
Yeah, great. Thank you. I'm assuming that you would need to have access to all those providers where you're running Pulumi from, right?
Absolutely. You need access to the key, because if you do not, unset AWS access key ID. And if I Pulumi stack change secrets provider, I believe we will, there you go, no credentials fine. So you actually need to have the correct credentials required in order to read those secrets providers as well.
Cool. Cheers, mate.
Any other questions? I have like 5 minutes left.
I know when we first were talking about this, that led me to put this together as a session. I know Alex had some questions about, I guess, how you prevent developers from going off and massively overcomplicating their infrastructure as software. Alex, I don't know if you want to phrase that in a more you sort of way, but that's what I took away from what you were talking about. He's muted or not paying attention. So let's answer that question.
Okay, so it's a great question. Software developers by default, I apologize if anyone on the call is software developers. I am one, and I'm an ops person now, so it's okay. We actually try and overcomplicate things like by default. That's just the way it works. Now, what Pulumi will allow you to do, Pulumi will allow you to complicate things as much as you want, and you can create as many abstract classes and all these different pieces that you require. but it will actually also allow you to keep things extremely simple. So one of the examples we created, this was like a talk for a non-Pulumi like example, like non-official Pulumi talk. It was like to a customer, and they came to us and they just posed a question. They were like, what happens if we have an ops team who want to create, give developers the ability to create like a simple Kubernetes cluster in Azure and also in Amazon? How can they actually not worry about hiding away, you know, understanding all the complexity of Kubernetes? So we created like this file where we showed that you can create these classes, and those classes can be packages, of course, but in these 14 lines of code, it actually will create both an EKS cluster and an AKS cluster using Pulumi. Now, all of the complexity is hidden away, but the complexity is hidden away for good reasons, because of the fact that good architecture means that, you know, Kubernetes is a crazy specialist thing, and people need to know how to build and manage Kubernetes. So we've given the operators the ability that they can create the packages that can be ingestible by the developers in this case, and we can go and actually have a look at what it does. So this is as complicated as you need your Pulumi code to be, where you have a class that extends the Pulumi component resource. A Pulumi component resource is the equivalent of a Terraform module. Okay, so they are like almost identical concepts that you can hide stuff away, and this is now making it a module, but in this case it's a class that you can instantiate multiple versions of the class in the same way as you can instantiate multiple versions of the Terraform module. You can have all of your outputs and your inputs, but each class has a constructor. The constructor, of course, will take the name, it will take any custom resource options, it will have a super so that it can actually inherit from what's happening inside Pulumi, and then you can actually hide away all the complication that you require. Notice that we're using additional secret outputs here so that we're not actually leaking any of the different pieces. But if you structure your Pulumi code in this manner, then this is as complicated as it really truly needs to be. Now, we have much more sophisticated examples, and they all sit at github.com Pulumi examples. And they usually stem around testing, because testing is the part in which developers can really go crazy. Okay, now let me quickly show you how unit tests in Go would work. Okay, so like we have our main.go, and we have an option where we create a new security group and we create a new instance, and we then, you know, just refactor it away, and then we export some outputs on it. Okay, so it's like a, you know, truly style Go. It's declarative, but it's written in a Go manner where you've like hidden some stuff away in functions that you could do it. Now, if you have a look in your main go.test, then you actually will implement from mocks and any mocks that you require. So anytime you create a new resource, you just implement the new resource functionality within mocks. And anytime you have a data source, you implement the call functionality within mocks, and you can do whatever you want inside this mock function, but you can really write truly testable code, and there, you don't need any credentials here. This is as complicated a Pulumi setup as I've ever seen. Like where you have testable code that is using mocks as well, then that is as difficult as people have made Pulumi. Now, of course, there are more than likely people who will continue refactoring and continue engineering Pulumi to make it even harder and even more difficult, but you just don't need to go there in that case.
Right. So it sounds like, I think you're saying that it is, it's possible to write straightforward Pulumi and keep things simple, but there's nothing inherent in how it's put together to sort of force you into not overcomplicating life for yourselves.
Absolutely. And like you know, it's perfectly acceptable if you have a Pulumi application that has 10,000 resources inside it and you want to do them declaratively one at a time the entire way down the list. Perfectly acceptable. Perfectly valid Pulumi. It will work just as well as Pulumi in a loop. Okay, and this is what we're trying to now show people, that you don't need to bring all these programming constructs that people inherently think when they read that Pulumi is real languages in order to get started with it. It's a pipe installer, a pip install, an npm install, a go get, and you have a Pulumi application scaffolded and up and running.
But once you're in languages, coding languages, then you have an entire set of tools that are already present to try to solve the problems of over complex code. I mean, you can lint this stuff. you can start linting your own code, and you can have it call out automatically going, "Hi, Sarah, why did you write 3,000 lines of setup code for this? You know, we try to keep it under 100.
Absolutely. And then even from that, I talked earlier about the Pulumi policies. So it's not the right one. I apologize. Let me find the correct example. So we have been able to use these Pulumi policies that actually allow people, here we go. So pack. So, you know, writing policies as part of your code. So in keeping with the ecosystem and writing the testability, there's a VPC and there's a version, you know, an EKS cluster that's built on top of the VPC. You can then write like testing code using policy, which basically says, you know, this stack shouldn't create more than X versions or X clusters. Okay, the version of the cluster should be 1.13 or 1.18 or whatever it should be. And then it can actually do things like, you should never create your EKS clusters in the default subnet that comes as part of AWS. Like force it like with your own custom VPC, and we can actually start to write these. So, you know, the languages don't do everything, but the language ecosystem, as Ryan has just said, give you the ability that you can start to take advantage of the tests to stop us doing the things that have got us as an industry into trouble, as well as like enforcing standard practice like linting and cyclomatic complexity. Because remember, you have cyclomatic complexity tools out there as well. If you run that through your Pulumi code and it comes up with this astronomical number as part of your pull request, then, you know, your pull request flow will say, you need to review this, you need to send it back. So it's a really good point. Thanks for making that, Ryan.
Cool. So we're sort of at time. Paul, I don't know if you've got a few more minutes to stick around and field some questions.
I have all day, John.
Right, and I have a certain amount of time as well. So I'll do a brief wrap up as intended, and then we'll come back and if there are further questions, we'll pick them up from there. So thanks for your time today, Paul. The demo and your experience and knowledge, very appreciated. I definitely have a better understanding of how Pulumi fits together now than I did. In terms of things that we're doing coming up in the near future, actually, if you just stop sharing your screen briefly, I'll do my thing. So things that we're coming up soon. Wednesday morning, I'm running a webinar on AWS Private Link. So if you are if you're a SaaS vendor in particular, and the way that you present your services to customers is currently very sort of public internet-y, then do join us next week, and I'll talk through some architectural patterns on AWS that can help you avoid that and satisfy certain compliance obligations and improve performance of your connections from your customers as well. So that's next Wednesday morning, I think 9 a.m. If you go to scalefactory.com/events, or just go to the Scale Factory website for the events link, there's a link to book that webinar. And you've probably also had emails and stuff about it from me as well, because I'm doing that now apparently. Then the 2 weeks following that is our breakfast ops event. So if you're a CTO or a technology decision maker in your organization, I run a monthly, so a metric monthly event. So every 4 weeks, an breakfast ops, which is on a Wednesday morning, and we choose a topic for discussion. We used to do that in person in the office with bacon rolls, but obviously we can't do that at the moment, so it's all online. And the topic for the 16th of September is going to be building operations capabilities. How you choose how to build your team, how much responsibility you provide development teams, like what's the kind of approach that you take for getting better at operations as a business. So if that's interesting to you, do sign up to that as well. That is not sign up for from the website, because I'm trying to restrict that exclusively to CTOs. So if you are not a Breakfast Ops mailing list subscriber and you'd like to hear about those, please drop me a line after we're done here, john@scalefactory.com, and I'll make sure you're on that list. It'd be good to have you there. The other thing to call out as a thing that we do a lot of at the moment, the AWS Well Architected program is it's a set of good practices for building infrastructure on AWS. we joined this program in April 2018, and part of what we do in collaboration with AWS is review AWS practice for you. So we'll come in, spend half a day with your team, sort of asking questions about how your platform's been put together, the architectural decisions you've made, and so forth. And you go away from that with a list of recommendations, a sort of more detailed report about where you should be spending your time. And if you choose to engage us to make changes to your platform to fix the high risk issues that we identified in that review, there are funding credits available from AWS to help support that activity. So, and if you have multiple AWS workloads, for example, if you're running an e-commerce platform and also a BI platform next to that, that's 2 workloads. Those credits can apply twice in that case. If you're selling a SaaS platform and you deploy a single AWS environment for each of your customers, because that's how your tenancy model works, again, each one of those environments is a separate workload for the purposes of this well-architected program. So do come and talk to me if you are interested in getting an idea of where you might be able to make improvements on your platform. I should also say, if you're looking to build a new product out on AWS, or you are looking at a migration, well architected is a good way to kind of look at that and think about the planning of it. B, we also have access to other funding programs through AWS as a result of our partnership with them, that can help fund things like migrations or new builds. So if you're doing new things on that platform, do let us know. So thanks for joining. Do stick around if you like and ply Paul with additional questions. Otherwise, thanks for joining, and stay in touch. So let's go back to questions. I know Marco has patiently had his blue hand up since before I started talking.
Yeah, sure, John. So just another quick question for Paul, actually. So since there are a lot of kind of parallels with the Terraform offering and what the HashiCorp is providing on there, and I was just wondering if Pulumi SaaS offering has the VCS providers support or kind of pipelines triggers available already, or this is something that is planned?
I'm really sorry. I don't know which providers that you mean. Can you?
So if there is an integration available with GitHub, GitLab, and other,
Oh yeah. So we actually have GitHub and GitLab.
Yep.
Yeah, we have GitLab and GitHub and GitLab providers, of course, and we have CI/CD guides. In fact, I can share my screen quickly. Sorry. So we actually have like an entire section on our site which shows how you get up and running with CI/CD for all of these different types of providers. And the interesting one for anybody who's in the Kubernetes world is we just launched our Pulumi Kubernetes operator, which will allow you to run CI/CD of your applications from within your Kubernetes cluster. So yeah, they're all there. We have a specific GitHub app which you can install as part of your GitHub org, and you will get full. Let me show you what it gives you. It will actually give you things like the resource changes and the link out to where you're actually storing your state, so that you can actually go and inspect any plans that come with it. And of course, we have all of the different steps and linked up in how you would actually do that. And what day is today? Today is Wednesday. Today is the GitLab commit. So I can actually tell you that today we are launching a GitLab app that you can install as part of your GitLab installations, which you will get the same functionality. So it's okay, I can say it because it will be recorded and it'll be played after we've launched it. So it's fine.
Good stuff. Cheers.
Adam, you have another question.
Actually, possibly just an observation. So harking back to my question about when the suffix of the auto naming part. So in the preview, it had a different thing to the actual. And I think basically my belief when I first started looking at the screen was coming down was that a preview is equivalent to a plan, and I'm assuming that they are actually distinct. Now that a preview is not a plan in like a Terraform sense.
A preview is a plan. Yeah,
okay.
A preview is a plan. And when you run a Pulumi up, the flow is that it will plan first, it will tell you what it's going to do, and then it will actually apply that. There's no way at this current time, as of August 2020, that you can save that and apply it later, but that is one of the biggest features that we're actually planning for Q4, so that you can actually go and actually save a plan and then apply that plan later. But
Okay.
a preview is a plan. We have different terminology. That's all it is.
Okay. Yeah. Yeah. Still a bit surprised to see that suffix was different. That's all. But
Well, the suffix is different between the code and the plan only, but the plan to the apply is exactly the same suffix.
Okay. Right. Thank you.
So going back to your earlier slide, Paul, where you showed, I think it was the Kubernetes and the Prometheus implementation stuff. You were using in the code. You had Kubernetes essentially sort of you're standing up a Kubernetes cluster and then doing something imperative in line with that to make a query of your Prometheus metrics, and then doing something else. And I'm 100% clear on the relationship between that imperative part of the code and what goes on in the sort of plan apply equivalent.
So great question. So this is actually written in a library that I can't share, unfortunately, just because of the fact that it was written by a customer. So what they've done in here is that they have wrapped Prometheus with check app metrics. So they inside the check app metrics library that they've written, it's just a file on disk, nothing else. They have implemented the Prometheus SDK. You can wrap anything in Pulumi when it's a preview by saying if is not dry run. So a dry run in Pulumi is the same as a preview or a plan, and it will actually then just skip that entire thing. So all of this advanced orchestration would be to say that it's going to create 3 and then 10, as part of the plan. That's all it's going to do. It's not going to talk to like Prometheus as part of the plan here.
So at the point at which this applies, then the imperative things are firing between
the imperative nature comes in and it works its way down, because it's actually this comes back to what I was saying. It works on promises, and the promise isn't available to be resolved until apply time. So Pulumi doesn't realize that it actually has a promise to resolve at plan time, because it's only going to give you an output of exactly what it's going to do at the end, but it doesn't know how it's going to get there in the in-between, because it's all based on promises as it goes.
Right. And so the plan, if I see the output of the plan for something like this, am I going to see the two applications of those two things, but with no sort of dependency in it? Okay.
Absolutely.
So it's sort of the superset of things that might happen as a result of the...
It's the superset of things that will happen, or it's the desired state of what will happen, as long as there's not in this case, it would be a failure talking to Prometheus or something like that, but the application would bomb out before it even does that.
Yeah. And in the event of that kind of failure, I'm assuming that your representation of the state is sort of, maintained appropriately. You're not just going to shit all over the state in the way that early Terraform used to do.
It's not just going to kill it and you're in this partial state world. It's actually as something changes, the state changes at that point, and it's using snapshots to do that. So every sort of operation has a snapshot. In fact, I can show you in the SAS super fast. Where are you? Where have you gone? There we go. So if I go to app.pulumi.com, and I think I called this project Scale Factory. Okay, cool. If I go to Scale Factory Secrets and Dev, because I did more in the secrets one, you'll see every single operation has its own entry in the state, because it's all represented by their own individual snapshots. And we can even go and see what happened in that individual file. So the timeline of events, any configuration in the environment, any policies that we enforced as part of that. But more importantly, we get the changes, we get the diff, we get any diagnostics that go with it as part of it. So if we can go back to the activities and where I did This is the change secrets provider. So there's no logs, of course, because it only changed the secrets provider under the hood. It didn't do anything else. Whereas if I go back and have a look at where it created resources, you will see as part of the creating resources, the diff that it actually created. So everything has got its own individual unique snapshot. Any operation that happened on any resource at any time.
Gotcha. So I guess whilst you don't have the ability to save a plan and apply it later, which would sort of help in certain compliance change control environments, you do at least have recordings of every change that's made.
Yeah, absolutely. Even when you're using the S3 backend, the S3 backend will save a point in time using a date timestamp so that you can actually get individual operations as they're happening. Notice in the SAS here as well, this is the first value that was created, but the other values that were created are encrypted, and Pulumi has no idea, like the SAS has no idea how to decrypt these because it doesn't even know the key that they've been encrypted with. Okay, so it's not like we're storing your encryption key or anything like that.
Yeah, good stuff. Any other questions from the floor before I pitch in with another one?
Come on, keep them coming, John.
It's just me then, apparently. Right. So I guess one of the things that I see with Terraform, which I don't do a lot of these days because my job is email and spreadsheets at the moment, rather than pressing the plastic squares in the right order for code. One of the beefs that I have with Terraform is that there's a bunch of parameter validation that Terraform doesn't do, but which the AWS API does. Things like the appropriate formatting of a name, like does it have the right sort of is it too long, too short, whatever. Those sorts of infuriating things where you run the plan's like, yep, that's fine, you apply it, and then you get a load of API errors because you're not sort of writing appropriately to the environment. Is there anything that you're doing in Pulumi to improve on that? I guess some of those are sort of invariants on strings, but some of them are also related to the existing states, right? You can't use this name because it's already taken, or that you've used a string here that should refer to another resource that doesn't exist, or those sorts of things.
We're not directly doing anything around validation of things that are currently used. But of course, your application can do that very easily because you can implement at any time in your code, like just crack out the AWS SDK, and you can actually make like your own like checks to make sure before you try and run your application. One thing that we're trying to do, and I'm just going to share my screen again. So I told you before that we basically rip off the Terraform schema, and we don't make any like bones about that. We actually don't lie about that. You can actually see here's what the Terraform resource would be. Here's where it would sit inside the Pulumi SDK. Now in here, we actually have a lot of, there's like some configuration here, like max length. So, we can actually start to implement these style functions around naming and around validation of naming. So AppSync functions, the separators, when we add auto naming, you can't have just the normal dash. It has to be underscores in the name. It can't be more than 255 characters. And then any random length that we actually add to it will be a maximum of 7, So we're able to do these different types of pieces. And if I show you the auto name options, what's this one? Glue catalog database has to be underscores. We're trying to adhere to like some of the what's out there right now around max lengths and all these different things. And as people are reporting them, it's super easy for us to fix them. We just need to add them to the schema, and it's really easy to generate a new schema and release it.
Yeah, gotcha. Cool. And I guess final and not related to this question from me, we've talked a lot about the comparison point between Pulumi and Terraform, and I think that's broadly because it's sort of the most similar other tool, and I think probably the most prevalent in use amongst the people that have dialed in today. Can you give us a sense of how Pulumi compares with, for example, CloudFormation or perhaps more sort of similarly CDK and the new CDK Terraform implementation?
Okay, great question. So I get this a lot right now, especially with CDK Terraform. So Pulumi doesn't emit anything in the middle. Okay, CDK will emit a CloudFormation template. You still have to run it. You still manage it yourself. It does effectively no state. Okay, because it's a point in time. You apply the same CloudFormation, and then AWS under the hood will take care of it. The same thing with Terraform CDK. It will emit Terraform templates. And of course, then you're in this scenario that if somebody manually changes the template, but hasn't gone back and updated the CDK, then you could potentially overwrite your changes. Now, Pulumi is similar to how Terraform is in the fact that it is a direct integration to the clouds themselves. It doesn't have any transpiled intermediate, okay? It makes raw API calls. It actually talks directly, and it will allow you to create the state that's saved there. Now, where it differs from something like CloudFormation is that, of course, you know, a lot of potential frustration with CloudFormation is that, yes, you can YAML lint or JSON lint, but effectively you're at the mercy of what happens inside CloudFormation, and you may have to wait an undetermined amount of time before you get a potential error back. As we are talking directly to the APIs and we're able to do things in parallel, we're able to get like plan time errors back, you know, especially around like malformed names, all these different pieces. But the most important thing is that we actually get compile time errors based on the schemas that are there. So it's no secret that we know we have to move away potentially for our big providers. So AWS, GCP, and Azure, we have to move away from the Terraform style management of those, because let's be honest, Terraform are also at the mercy of being a third party. It's slower to upgrade. You know, they have to wait on pull requests. They have to wait on like API changes that filter their way through. So we are exploring ways that will integrate directly with the clouds themselves that will allow us to have a much more of a native style scenario. And because of that, we will then be able to take advantage of the actual things that happen within the cloud SDKs themselves, rather than a third party that sits across the top of the cloud SDKs. So we're different purely because of the fact that we're making the direct API calls. We don't need the intermediate. The same thing happens in ARM templates as well, like in Azure, because they're also at the mercy of throwing it up into Azure and then seeing what happens. But of course, if you're in a situation where you're not just AWS or not just Azure or not just GCP, then a solution like Terraform or Pulumi will actually work better, because it gives you access to all of the other providers that you need. And any provider in Terraform can be scaffolded as a Pulumi provider in less than 1 hour's work.
Cool, good stuff. Great. I think unless there's any more questions from the floor, we can probably wrap up.